What's going on, my IED engineers? This is Mr. Suffering here. Today, I would like to go over activity 1.2.4, Fundamentals of Dimensioning. So let us get to it. Okay, here in Canvas, make sure you go to the link. It is active for activity 1.2.4, Fundamentals of Dimensioning. At the end of this two-day activity, what I want you to take away from this activity is just you having the ability to identify errors and omission in multi-view drawings. You will be able to generate and annotate multi-view drawings using CAD software, i.e. Autodesk Fusion 360. As well as you're going to use each other to give and receive feedback to influence personal and professional development in this activity. We will be using a great bit of Autodesk Fusion 360 to create sketches, multi-view, and add line, our line types, as well as our dimensioning as well. Okay. Take a look at your resources. So your first resource, you have a link that will put you directly to the PLTW activity. You're going to use dimensioning examples. That's going to be one of your activities. You're going to be utilizing isometric paper, orthographic paper for your multi-view sketches, as well as your dimensioning flowchart, which is another activity. But before we partake in our different activities that we're going to complete today, I want you to download the Introduction to Dimensioning slide deck. This is a PowerPoint presentation provided to you. You should have a hard copy of the Introduction to Dimensioning notes, okay? So what I am going to do, I am going to share my screen so that you could view the notes as well as the slide deck. So let me look for it real quick. Okay. Okay, sorry about that, guys. On your screen, you'll see the slide deck for your Introduction to Dimensioning. What you are to do is go through each slide and take notes on each slide. The notes will guide you as to what step you need to go to next. Okay. But the whole purpose of this is for you to read and take in the information that you need to understand relative to how to properly dimension your object. Okay. So you're going to take a look at slide 3, which talks about drawing a particular your object to scale. You are not going to measure the object itself on your multi-view drawing. You're going to reference the actual size of the object. So that's what you are to do, is take notes on all of these different slides, okay? There are about 32 slides. So take notes on that. And when you are finished with your notes, let me stop sharing here. When you have completed your notes, we're going to go to the activity and let us go to it. Okay. Okay, here we are in our activity. Your Canvas side of the curriculum should mirror the PLTW side. So when you scroll down, you are responsible for reading all of this information. It talks about annotations, standards. Take a look at all of those, all of the information that is on the course, okay, on a course activity. Number one, as a group, I want to say about groups of 2 or groups of 4. I want you to take a look at the activity 1.2.4 dimensioning cards, okay? And let me go to that one. I believe this is it. Okay. This is activity 1.2.4 dimensioning cards. What you are to do is identify dimensioning errors and omissions in the drawing and justify your interpretation. Okay, so if you take a look at the object with a notch in it, you'll see drawing 1A and drawing 1B. They're the same object, but they are dimensioned differently. You're going to determine, based on the information that you have learned in the slide deck, as well as your notes, you're going to determine which drawing is the correct way of dimensioning. And I want you to articulate in your engineering notebook why is drawing 1A or drawing 1B is the best drawing that has been dimensioned efficiently. I want you to tell me which portion of the drawing is not dimensioned correctly. Okay, I want you to articulate that. Okay, so I want you to just to converse with your table partner, and I want you to just bounce ideas off of each other, and you all just jot down in your engineering notebook why drawing 1A or drawing 1B is the correct is dimensioned correctly, and just also articulate which portions of the drawing is not dimensioned correctly. Okay, you're going to do the same thing for drawing 2, as well as drawing 3, as well as drawing 4. Okay, so that is step 2 of your activity. And okay. Okay, also on step 2, you will take a look at this exemplar and how they are dimensioning this object with a notch and a hole. And we're going to go through this when we're looking at our dimensioning examples. Take a look at this important fact with regard to dimensioning circles and arcs. Use a center mark and center lines to indicate the center of a circle or an arc. Okay, so again, if you are indicating the center of a circle, you're going to use a center mark. If you're going to indicate an arc, you're going to use a center line. Okay, next bullet, you're going to use the symbol, this symbol right here with it looks like a 0 with a line scratched out to indicate the diameter of a circle. And bullet 3, you're going to use a capital R to indicate the radius or the size of an arc. Okay. So number 3, let's take a look at it. In the class, you're going to have you should have activity 1.2.4 dimensioning flowchart. You will, this should be hole punched, which you can put it into your notebook. You're going to refer to this flowchart when you are dimensioning, okay? And let me see if I could enhance the view a bit so you can see it a little bit better. Okay, so let's take a look at this interactive flowchart. this is a flow chart, and it's going to step you. There's 8 steps in how to properly dimension your object. So let's get to it. So if you take a look at the guidelines on the top left-hand corner of your screen, you'll see step 1, match dimensions precision to measurement precision, okay? Number 2, only dimension the views that accurately show a feature, okay? So, and then if you take a look at this flow chart, we're going to begin with creating a multi-view drawing, okay? So a multi-view drawing consists of your isometric sketch on the top right-hand corner of your page. Then you have your 3 orthographic projections, your top view, your front view, and your right side view, okay? These guidelines will help you right here. Never dimension to a hidden line. Do not underdimension, do not overdimension, do not cross dimension lines. Leave a gap between extension lines and object lines. Avoid crossing leader lines. So all of these guidelines you should have taken away from the notes on the slide deck, okay? So let's take a look at the flow chart. First, the first command, you're going to complete a multi-view drawing. Look like we have done that, okay? So let's go to our second step. Okay, now your second step you will need to do is count the number of features. So let's take a look at this object and let's count the features. Your first feature is the notch on this block right here. So this notch is considered a feature, okay? All right, another feature would be the hole. All right, so the hole would be a feature. And the third feature would be the best view of this object on this multi-view drawing. And the best view would be the front view, okay? Because it shows most of the contours of this shape. So now that we have counted all of our features, we're ready to move to the next command. And let's go ahead and just click right here. All right, so now the next command says, select the best view to represent each feature, okay? So which is the best view? Well, the best view would be the front view. Feature 1, notch, best view is the front, and the secondary view would be the right side, okay? Because these are the 2 features that these 2 sides really reference, okay? So now that we have selected our best front view, let's go to our next step. Okay, so our next command, it states dimension each feature according to size and location. So again, dimension each feature according to size and location. So we have feature number 1, okay, the notch. So we're going to dimension the notch as follows: 1.5 inches long by 0.5, okay? So now that we have our feature, all right, now that we have dimensioned the first feature, we can go to the next command. And the next, well, it's not a command, it is a condition. And it states, is every feature fully dimensioned according to size and location? If not, you're going to go back to this command, select the best view to represent a feature. Dimension each feature according to size and location. Well, we've already dimensioned feature 1. Well, now we need to dimension feature 2. Okay. And notice, I'm sorry, let me just back up a little bit. Notice that we have, well, let me just move forward. Okay, so feature 2, the right side view is the best view to dimension this particular feature. Okay, so when you're dimensioning the hole, make sure you add the center mark because it's a hole, okay? Between the hidden lines, make sure you add the center line as follows. Okay, so now we have to dimension each feature according to size and location. So we dimensioned the notch. Now we need to dimension the size of our object. So we have 3 inches by 1 inch width. Okay. We also measured the dimension or the diameter of the hole, which is 0.25 inches. And the location of the hole is a 1/2 inch from the edge of this notch right here. I mean, this shape. And it's also a 1/2 inch upward from this end right here. So we have dimensioned the size, location of each feature. Okay, then the question still arises. Is every feature fully dimensioned according to size and location? Well, obviously not. Then let's select the best front view. Okay, now we have the height of our block, 1.5 inches tall. Okay, again, now if you could see this flow chart is iterative, all right? So if we didn't satisfy this question, we have to repeat the process. So let's go ahead and repeat the process. Is every feature fully dimensioned according to size and location? Absolutely. Okay, so if every feature is fully dimensioned according to size and location, then it says dimension overall object if needed. All right. Does every view has at least one dimension? If no, then go ahead and delete the view that has no dimensions. And then we're at the end, okay? So what I would like for you to do is when you are dimensioning your objects, please utilize this flow chart, okay? Utilize this flow chart just how we just went over it. All right, let me scale down my. All right, so number 4, I would like for you to, we will get to number 4 during our next class meeting. But here's your exercise for today. Now that we went over how to properly dimension our objects, you're going to use the worksheet that I have provided to you. And I'm going to share my screen and show you that. Let's see, where is it? Okay, here it is. Let me close out of this and let me share my screen. There it is. There we go. All right, so I want you to go to the PLTW side and use that interactive dimensioning flow chart. You will have this literature right here for yourself to take it home with you, to look over it and study it, because your quick check assessments will be coming from the slide deck as well as this flow chart, okay? I would like for you, okay, I think I need to stop and reshare. Okay. Your next task, you will have an opportunity to fully dimension your objects. So right here, you'll see activity 1.2.4, dimension the multi-view drawing shown. use fractional lines to the nearest quarter inch, okay? Notice the scale, okay? So it has 1, 2, 3 lines. 3 of these lines equal an inch, okay? But if you rather measure this out with a ruler, feel free, okay? Feel free to do that. So what I would like for you to do is dimension these objects exactly how we went over it with the dimensioning flowchart, okay? So you're going to have the dimensioning flowchart out available to you, and you're going to go through all of those steps to dimension drawing 1, 2, and 3. Make sure you take heed with regard to the guidelines, okay? All right, this is a graded assignment. So I'm going to grade this, and I want you, I'm not trying to turn you into an expert, but I want you to just do the basics. So go through the guideline, the dimensioning flow chart, and count out all of your features, pick the best view, and dimension your drawings exactly what you've seen, what we went over on the dimensioning flow chart. Okay, so you have, again, you have drawing 1, you have drawing 2, and you have drawing 3. And if you take a look at these drawings, each drawing progressively get a little bit more difficult. Use your peer review. Use each other as resources to make sure that everyone in your group is dimensioning these drawings efficiently and correctly. Okay. I think that's all for today. We will revisit this and finish this activity off in our next class meeting. Make sure you put your names on your documents, save your documents, because you're going to be submitting all of these, the classwork on a Google slide. So make sure you take a snapshot, put it on a Google slide, and as well as make sure you keep your documents, because I am going to come around and grade them. All right, so that's our time. Have fun with this, tinker around, learn as much as you can, take a few minutes every day, study this literature, because you will see it on a quick check assessment. Okay, have a great rest of your day. Peace.